Yeah.
I will just ask for one more minute,
Yeah.
to everyone, and then we begin.
It started.
Very good.
Okay.
Almost ready.
Hello, everyone.
Let's wait 1 minute and then we start.
Yes. Indeed. And I would like to ask, to begin with, I would like to ask if it is okay for everyone if we record this presentation. So otherwise, I think Boris, have you been starting the recording, or should I start it?
You can start it.
Okay, I will. Oh, of course, there is the Boris. Now you are the host, so you have to make me co-host before. Yes, because otherwise I cannot share my presentation.
Okay, now you're the host.
Okay, and maybe we can start.
Yes, I think we can. Mm-hmm.
Okay, so good afternoon, everybody, and ciao a tutti. We are very happy to welcome you to the QCards Online launch event. QCards Online is our new game, is a multiplayer version of the previous table card game QCards. But I would like to start sharing with you a couple of words about the context in which the game has been created and developed. And this is QPlayLearn. QPlayLearn is our online platform that you can find at qplaylearn.com. And this platform contains multimedia resources to learn about quantum science and technologies in a playful way. Most importantly, QPlayLearn is for everybody, regardless of their age and background. And when we say for all, we really mean it, because it's true. We are all quantum physicists behind it. We are all super enthusiastic about the quantum world. But we truly believe that anyone can learn and understand the beauty of quantum physics and the power, the potential of quantum technologies. We think that this can be done even exploiting games and there is an echo. Okay, so I was saying that we think that this can be done even exploiting games and having fun. And indeed, not by chance, we are here today to introduce you our new game. But on the platform, you can find many animations, videos, and other games, including a tutorial with mermaids to learn a bit more about the physics behind QCards Online. But it's time to introduce you the people behind QCards Online. So first of all, Professor Sabrina Maniscalco, CEO of Algorithmic and from University of Helsinki, will tell us something about the history of the game QCards, how the game has been created. So ciao Sabrina.
Yeah.
Yeah. And then we'll learn a little bit more about the game developing process itself with the game developers Victor Minin and Sonia Minina and Boris Sokolov. Hi, guys.
Hi.
Hello.
And hi. And finally, the first official online, the first QCards Online game will take place, and our special guest players will be Dr. James Button from IBM Zurich. Hi, James.
Hello.
And Professor Marilu Chiofalo from University of Pisa and part of the QPlayLearn team. Hi, Marilu.
Hi, everyone.
And instead of Dr. Matteo Rossi, CTO of Algorithmic, for technical reason, we'll have Dr. Boris Sokolov, part of the QPlayLearn and Algorithmic team as well. So, Boris.
Yeah.
But we can also say hi to Matteo.
Hi, Matteo. Yes, Matteo is also here.
Hello.
And is also part of the team creators behind the game. So, yes. Okay, time to start and enjoy.
Thank you very much, Caterina, for the presentation. And now I will share my screen and I will briefly talk a bit about how QPlay Learn came to existence. So let me just see. Do you see well the full screen?
Yes.
Yes, very nice. So I will begin just by saying QPlay Learn is proud, very proud to present a brief history of QCards and what we think makes it unique and makes it a very, very nice game. So I will begin. Caterina already went through the schedule of our meeting, so I will not repeat it. And I will directly begin with the origin of QCards. That were a beautiful event, a quantum game jam in 2019, the Quantum Wheel, for reasons you will discover very soon. And during the Quantum Wheel that was co-organized by us and by IBM, we went through a number of games, including QCards. So this is where the Quantum Wheel happened, in a real Quantum Wheel. Here are some pictures that I will show you of this event. That's why the name, of course, of the Quantum Game Jam in Helsinki. And I would like to show you a video from the event, recorded at the event itself. I hope that you will hear also the audio I started. We are at the very beginning of what promises to be a new era, combining games and game industry and quantum physics and quantum technologies.
What I've seen so far is a lot of people.
Yeah, Sabrina, we do not see the video, even if we hear the sound.
Oh, okay. Oh, that's a pity because, well, so you could not see anything of the video.
No. And probably even one slide that you showed, then we didn't see it.
So this one you didn't see. Okay, let me just try to figure out what this technical problem. Do you see now?
Yes.
Okay. So did you see this slide before?
No.
Okay, let's see. Do you see the video?
No.
Okay, I do not know why. Of course, I can probably try once more. This will be the last time. Hopefully it works. No.
Can you share just the screen, the whole screen?
Oh yeah, this is a good. I will try again. Let's try to do it. I will share the whole screen. You say, not just the desk. So the desktop.
Yeah.
Okay, I try. Sorry for this. Do you see it all dark now?
Yes.
How about this?
Okay.
We are at the very beginning of what promises to be a new era, combining games and game industry and quantum physics and quantum technologies.
What I've seen so far is a lot of people who don't necessarily know much about quantum computing, but are very excited to learn enough to be able to incorporate it into their game mechanics, into the style of their game. So a nice openness to learn about quantum computing and do something interesting with it. At the moment, quantum computers are a very new thing themselves. So what they can bring to game development is a new way to explore something in science. What quantum computers can bring to game development in the future will be interesting ways to, say, do procedural generation. So this random generation of content that you get in many games now, it's hampered by the fact that you need to make a game that's actually solvable. And this is going to be a lot easier on a quantum computer.
I think that the most interesting thing is to bring together people belonging to completely different communities and see how different types of creativity interact with each other. So it's really this multidisciplinary aspect, because we have really experts in computer coding, in graphic design, and audio people, and quantum physicists all together. And I think that what comes out from this mixture of expertise is really well, particularly interesting and new. And obviously this year we have also the IBM Real Quantum Computer, one of the few in the world, and the only one accessible to the public. So it's particularly new, and it's something that has never been tried before.
I would imagine that quantum computers are going to be very positively affected by new people coming into the community, and that's what we want to try and encourage at this point.
So this was what happened in the Quantum Game Jam. You see some pictures of the event. And during this Game Jam, a team of quantum physicists and computer developers, so game developers, graphics artists, and so on, were together. Here you see in the evening our sauna place, where we had very nice time and chatting about physics and games. And eventually we had a number of games, including the first version of QCards. And some of these games use the black box.
I think Sabrina is frozen.
Yeah, same for me.
Mm-hmm. Okay, let's see if she will be back soon. If meanwhile the people who were at the event would like to comment a bit.
Well, I was there, and it was interesting to hear my past self talking on that Ferris wheel there. But yeah, it was really nice to see all of the people, a lot of them coming in with no experience of quantum computing. People often, when they have the ability to make a game, they often just make it as use the quantum to be a random number generator. So what's always very interesting is to see people going beyond that and to actually try to use some basic gates as a game mechanic, as a learning exercise, which we saw a lot of in that game jam. So that was quite interesting. The one with the USB stick that you see the thumbnail of him, what Sabrina was showing, very much did just use the random number generator, but a lot of the others were a lot more sophisticated. And QCards was a great one because it was intended as an educational experience. It takes the process of putting down gates to make a circuit and makes it into a game. So there's no boundary between what you do when you're doing quantum programming and what you do in the game. So it makes it a great way to be the basis of a learning experience. Yeah.
And it is really something from which persons learn from each other in the most effective and also joyful manner.
I'm sorry.
Okay, Sabrina.
Sorry for these inconveniences, but we are back. At least I'm back. And now the next question is, will I still have the presentation or not? I will try to open it up, open it and see, yes, and see if, yes, it's here. Perfect. So I will try to share it again. Sorry for this. It's interesting how, I mean, this type of, this never happened before. Okay. Now it decided to happen. I will share now and try to see if this works. So, yes. Do you see the screen? Yes?
Yeah.
Yes.
Fantastic. Very nice. Okay, so yes, I was just showing some of the pictures of the event. This is the final presentation that we had of the first version of QCards. And I was saying how some of the games were using really IBM quantum computers. They were written in order to use a real quantum computer, while others were using other devices like the black box. And yes, this is funny, but
Some advertisement.
Exactly. No, it is some advertisement, but I don't even find anymore. Yeah, okay, the presentation is here. Yes, this is the point in which it gets stuck. It's really funny. Okay. Anyway, QCards was born in this way. So this is one of the first picture in which we were drawing on a piece of paper, really the action of the so-called quantum games. In the team, I was part of the team. Guy, our CSO from Algorithmic, was part of the team. Jordan, that you see here on the is tagged on the upper left side, was part of the team. And here you see us playing at the game jam with the first printed version of QCards. They were, of course, in black and white, and we were using pebbles in this original first version. It was a lot of fun. Here we are playing with Oskari and Samuli, the computer coder, and with Guy on the side, on the wheel, while we were on the wheel of in Helsinki, so on the ferry wheel, and eventually there was, in the very first version, a computer. In the computer we had to enter one by one the gates for the different players, and then one could simulate with noise or otherwise directly run on a quantum computer. So the very first version was already playable, but it was on a computer, and contained, we also developed the list of instructions on how to play the game. So on how to, in a way, in some sense, program a quantum computer by using these cards. Okay, software updates. I don't want to do the software updates one by one. And so this was already part of the initial version of the game. The initial idea was really to try to intuitively propose a way to operate the quantum bits that are the individual units of quantum computers by performing certain operations which were encoded, the meaning was encoded into this card to play. So this was the video presentation of QCards that we developed during the game jam. And these were the card as they were developed subsequently when we colored them. So we started immediately after the game jam to work with the graphic designer, actually maybe not immediately, but to work with the graphic designer in order to complete them fully. And in this way, we obtained a version which was then printed. So the version of QCards after the game jam was really printed card games, and the developer that were at the time Mitel company were developing at the same time an app which is still available online in order to scan the cards and to somehow play or to transform the order of the cards into instructions to be run on quantum simulators or quantum computer. Of course, this required really the physical cards to be present together with the app to scan them. And obviously, in a way, while this was a possible option, it definitely was more difficult to achieve, especially in 2020, 2021 with COVID time. It was initially, we started to organize some workshops with the school, but we had to be interrupted because of the situation. So we thought it would be fantastic to develop a version that is fully on a mobile phone, that is multiplayer, that does not require the physical cards, and that therefore can be done remotely. And this is what was created by Victor and Sonia. Here briefly, I flash through the design. First of all, it's a game that can be played, that really can be played remotely on the quantum computer. I will invite you all to try it in a moment. It is a game which, as I said, allows to try to learn the action of different quantum games and therefore to program real quantum computers, and that can be played by up to 5 players. It can be played as a quantum simulation or also as a real quantum computer simulation. And there is a tutorial Caterina mentioned. The tutorial is here in QPlay Learn. It's a tutorial that explains the action of the gates, and in particular, it uses also some simple illustrations to somehow explain the physics behind each of the quantum gates. I want to conclude by saying another thing that was a very recent one. So after the creation of QCards, really the card game, we were invited to an exhibition in Dipoli. It was an event for the quantum technology flagship. Here there are some pictures. So we created, I was the scientific director of the quantum exploration exhibitions, and during that exhibition, here you see some pictures for the event with the Alto Rector, which is giving a speech for the opening of the event. And during this exhibition, we also exhibited, here you can see in the left corner, QCards. And there were many people attending. And in particular, just today, we discovered that there was on the archive an article, a preprint of a quantum card game by a group of physicists in Finland, in the University of Tampere, and they developed QCards further to incorporate more than two-level systems, but higher dimensional systems. And we just discovered it by chance this morning, so I just wanted to express my happiness to see how what has started in 2019 has been continuing in such a wonderful way. And now I apologize because this has taken a little bit longer with respect to what we initially planned because of the so my presentation, because of all these technical difficulties. But nonetheless, I would like to thank all the sponsors that have been continuously supporting the development of QCards. I will stop sharing my screen, and I would like at this point to give the word to Boris for a dialogue with the developer, so with Victor and Sonia, who have been taking care of creating this amazing, wonderful app that soon you will all have available to play with. So, Boris.
Yeah, hi everybody. My name is Boris Sokolov, and I'm currently a lead researcher at Algorithmic, and I'm also at the same time a postdoc in the Helsinki University. So my participation in this game was mostly physics part and a little bit of coding of this Qiskit server that calculates the results and sends them to the real quantum computer, sends the jobs and everything. And obviously, I'm not like a real coder, so probably all this part will have to be redone in a later version. But it's at the moment it works well somehow. So so yeah, I guess I can ask a couple of questions to the main developers, who are Victor and Sonia. First of all, what is your game design background?
Hello, everyone. Can you see me?
Yeah, but you should. Okay.
Hello. Is it the echo here?
Yeah, there's a bit of echo.
Sorry about that.
Hello. So there is no echo. Hello, everyone. My name is Victor. I'm the developer of the game. So yes, I did all the coding part. And we have also Sonia here. She did all the graphic design part of the game. Well, I'm ready for questions.
So yeah, the first question was, what's your game design background? Do you have you been making games before this?
Well, okay. As for me, I don't have a very rich background in game development. Actually, I'm an enterprise programmer, and sometimes I make games as a hobby. I participated in several game jams and have a few own small projects. And this is my first multiplayer game, and well, that's all for me, I think. What about you, Sonia?
Okay, I'm Sonia, and I have some background in game development. Actually, I work as a UI designer and interface artist for my game group. This is one of the biggest studio of mobile game in Russia. But QCards is my first completely owned project, apart from a small game, Quantum Key, which we created in Quantum Wheel 2020.
Thank you. Very nice.
All right, thanks. And when did you first hear about QCards?
Okay, as for me, as I said before, I participated in several game jams, and actually I was there when it was born in Quantum Wheel 2018. And there was the first time I heard about QCards, and but I was on other team, so we made another game. But yet I had the first acquainted with QCards there. So yeah.
Okay, if about me, I learned about QCards from Victor when he came back from Quantum Wheel 2018 and told me about this and white and how cool it was and all interesting project and game that were made. And I learned about QCard and quantum computer. It was really interesting for me.
So was it difficult to understand the idea behind this game without well, quantum computing background or quantum physics background?
Okay, I think it's not really easy for people who not work with physics or quantum physics, but I think it's my important tasks help for people to understand rules and mechanics our game. and make it more and make it easier and more friendly in tutorial and in game.
Yeah.
Well, as for me, the idea of the game is based on the very basic quantum computing. So for me, that I having a technical degree, it wasn't really very complicated, but on the same time, it wasn't that easy to just I don't know to understand in a minute. I mean, but I have some small understanding about the quantum states and the quantum gates. For now, it is, I think, enough. Well,
so you can say that you learned a little bit as well while making the game, a bit of quantum stuff. Yeah.
Yes.
Thank you very
So,
much. Extremely.
Can I have last
Yes.
question? Is there what kind of updates are planned for the future? Because this is still not the version 1, but it's 0.90 something.
Yeah, it is a very interesting question. Well, this is not the final version of the game. As you could see, this is the version number 092. The game needs to be polished a little. We are planning to add some music and sounds to this game. Also, maybe some graphics improvement. Also, we wanted to add the tutorial into this game and make it interactive, so people without physical background, physical background, could play this game and could actually just go through the tutorial and just play. Also, maybe we wanted to add some technical improvement. Actually, we had some difficulties setting up the server that is working with a quantum computer. And after that, I think we have some thoughts about adding new game modes and maybe advanced game goals. That's it, I think.
Okay, I'm absolutely agree with Victor, and I want to add some words about my graphic plan. I want to work with graphic style of some decorative element in game, and also work with game table, and I hope it will become more understandable and more user-friendly. And I want to add more animation and music and sound. That's all.
Thank you. We are very glad that you accepted this challenge of developing together both the code, Victor, and the graphic, Sonia. Thank you very much. And I know that you have been forming a fantastic team with Boris.
We were very glad to take part in this development. Thank you.
Very nice. So thank you also, Boris, for the fantastic interview. And now we will be going, now is the moment of playing. So I will be asking our two guests, led again by Boris, to please go ahead and show the
So
game.
I'll share the screen now. I'll be sharing the screen of my phone in a moment. Second.
Meanwhile, I would like to mention that the way to download, you can download already now the game on your mobile phone, both for iPhone and for Androids. And at the end, I will show the web page in QPlay Learn, where you have all the credits for both the previous game and the present game. And when you also will see the link to the app stores if you want, but it's already available to download.
Yeah, the game, if you look for it in the App Store, it's available. You just put QCards Online and it should be there. But for now, I'm going to show you how it works. So this is like the main screen. And you just tap the create button if you're like the main person, the host. So you create. So for example, here we have 3 players. And the mode things is not yet implemented. So we only have standard mode, and more modes will come in the future. And here you can set the number of cards or the number of rounds, which is the number of cards that you can use before the game ends. And I'm creating a server now, and we should have 2 more people joining. So Marilu and James.
Here I am.
All right, excellent. So, okay, now the game is starting, and the point is at the moment to change the state of your qubit to 1. And now, of course, they can see all my cards, so they hopefully.
What is his cards?
Yeah.
Oh, I was first, so I'm flipping my bit.
So he flipped his bit with a Y gate, and I will use a switch thing, a switch gate to, which is a 2-qubit gate to switch the state of James and me. In this way, I get the state 1.
But Mari is running out of time, so
yeah. Unfortunately, I thought it was Boris James.
Yeah.
Put a card.
Place a card. Put a card.
Put a card.
Oh no.
Doing that. No, I'm out. Everything is blank now.
Okay. Sorry.
I don't have a lot of cards available to me, so I am gonna swap back.
So I will use a steal card to steal a random card, which is a cancel card, and I will cancel the swap.
Yeah, these are gates not usually available in QuizKit.
Yeah.
Can I cancel your cancel? Oh.
Oh, we can cancel the swap.
Available, you know.
Yeah, so now I've cancelled your swap.
And then I will add this Hadamard.
Make it all nice and random. Now I've got a C here.
C is the control gate of the C note gate.
Yeah.
So you first.
Yes.
So that doesn't actually do very much.
Yeah, exactly, because my state was 0. Okay, so now the game ends and I won.
But if we ran one shot, I would have half a chance of winning.
Exactly. And with this button down here, you can request.
This looks to be constant of time, as it happened before starting the game.
It's possible. Well, when you run it on a real computer, then you have noise. So one thing I liked about it a bit when it was in its initial form at the game jam is that you can kind of tactically use noise. You can try and make it so even so someone's should get a 1, that you can add some extra nonsense in there that will make it less likely.
Yeah, like here what happened is that my score got diluted a bit because the quantum computer is noisy, and but I still won because of...
Maybe can you comment a bit about the difference between these 2 results that we can see here?
Yes, so the results in white are the results of a simulation. So it's an exact noiseless simulation in which well, the outcomes are sampled 1,024 times from the quantum circuit that we build with the cards, and because it's noise free, it means that if my state is 1, then it will be 1 for sure. While the green one, the results in green are the same circuit run on a real quantum computer. So there are real qubits to which we apply certain pulses. I think they're microwave pulses with some frequencies, and these pulses represent gates, quantum gates. But because these pulses are imperfect and the qubits are imperfect, the end outcome. So we do here. We also build the circuit 1024 times and do the final measurement at the end. The outcome will be slightly different. So from the perfect outcome, meaning that it's not exactly the perfect one, and it's not exactly a perfect zero. And James's case, it's not exactly a perfect superposition because he had like half and half.
So this can also explain why I have anyway a 68, even though
Exactly.
I didn't play. I didn't enter the game eventually.
So Marilou's qubit was at in a state 0. However, it had some in some cases it got some it was measured as a 1. Oh, sorry, because of the noise in the computer. All right.
So maybe, thank you. Do you want to play another game?
Yeah, let's try another game. So if I create another one with 3 players, and then let me change the name like this. So can you join now this this another room?
Looks like it.
Just one moment. Yeah.
Okay.
I think it's nice to note that even though there's been some technical issues during this presentation, the game was not one of them. We've got phones talking to each other over the internet and then talking to a quantum computer.
Yeah.
No problems at all.
Yeah, exactly. Although we had a lot of technical difficulties during the testing, but luckily we managed to iron them out. So now you both left. Okay, now I start the game.
Yeah, well, as soon as I said that, there was a minor connection error.
So Marilu.
Yeah.
Oh, start with a Hadamard. Interesting move. I'm just gonna entangle to you, Boris.
All right. I'm gonna give you another Hadamard in this case.
And now we're getting pretty deep in the circuit.
Let's do it like this.
My internet had a hiccup, so I'm just I'm just leaving this entanglement for you to deal with. Good luck with that.
Marilu?
It's your turn.
Actually, I did it. Here it looks like it got it, but it is not. It's not showing up in the.
Here are technical difficulties.
Yeah, in my
This is Boris.
My monitor it was given to be there.
No,
Boris is sabotaging everyone else.
Boris is just the king, okay, but this is not. This
no.
is not
He
good.
has an extra button. I don't like this player. They're going to win.
No, I think that Jim won this time, I think.
Yeah.
Yeah. So in this case, it's very much dependent on what the noise is doing and what the random statistics are doing, because me and Boris, in principle, should be equal, but
Exactly.
it's never going to come out exactly like that.
So you can, in principle, add like a bunch of gates that do nothing to this to 1 or 0, but in any case, they add noise, and in this sense, you diminish the other person's probability of getting a 1 outcome of 1.
Thank you very much. So I will be.
Thank you for fun.
Thank you for participating to the game, for playing. Let me just share with you. I want to share with you the screen of QPlay Learn, the page from where you can download. You can have all the information. I hope that you can see it. Do you see this?
Yeah.
Yes. This is the qubit page of QPlay Learn with the first version of QCards and the credits of all the people who contributed to the first version of QCards. And here you find the QCards Online with the credits and with the tutorial. And by clicking in the Google Play or App Store, you can directly download the mobile app. If you are new to quantum information, we recommend to read the tutorial where we explain by using this mermaid and mermaid men, so Alice and Bob, we explain the concept of superposition, of entanglement, and the action of each of the quantum gates. So what is the action of a quantum gate on a qubit, which initially is in 0, as all the qubits initially in the game of QCards. So you start with all the qubits in 0, and as Boris said, the aim is to flip them to 1 by applying gates. So I would like to conclude by thanking all the people who have been participating not only to this event. I apologize for the technical difficulties of different sort, but also most of all, I would like to thank all the people who participated to all the quantum game jams and to the creation of QCards in particular, and that are still enthusiastic about using or playing with quantum physics and developing games for education and for outreach. So thank you very much, James. Thank you very much, Marilu. Thank you very much, everyone. And thanks to our coder, developer, Boris, Katerina, everyone. And thank you for everyone who participated and also who is watching, watching the streaming at the moment. Bye, everyone. Thanks a lot.
Bye bye.
Bye.
Ciao.
Thank you. Ciao.
Ciao, bye.